Probably software would be wiser than an app, though, because software would be able to be on the computer. For those of you guys just joining us, sorry, you missed some of the recapping. I will go back really quickly on the computer as these guys are trying to fill in this triangle that is so blank and yet should be so full in just a moment. To show you what we went over really quickly. Talked about how the quest is going to be on Friday instead of Thursday because we got a little bit behind yesterday. I showed how some of these things I've been having you highlight all along are things you need to be memorizing for the quest on Friday. So reminding you of each of these little restrictions for sine inverse, cosine inverse, tangent inverse. But then we also kind of randomly talked about tangent and his vertical asymptotes. So I came back here to the graphs of cotangent and tangent, talking about their vertical asymptotes being the trickiest part of those graphs. And really the only important part for you guys to know about tangent and cotangent graphs for Friday. So we highlighted some of those, reminded ourselves of how important waves are and how to graph waves and how to graph cosecants and secants off of sines and cosines. But then we came ahead to the end of section 4.7. The problems that we didn't get to yesterday. And we started filling in the idea of if you have for an angle, an adjacent and opposite a hypotenuse, we can actually make a trig function like we did in chapter 4 from sine, for instance, opposite hypotenuse, cosine, adjacent hypotenuse. An inverse trig does normally just cross off regular trig, and inverse and its original cancel out. But then you get an inverse with a ratio of sides over here, reminding us that inverses get angles given ratios. But then we saw some tricky examples where it's like, oh, cross, 5 pi over 3. Oh, it doesn't fit in the range that's legal. So we had to go looking a little bit deeper to find an angle that had the same exact value, ratio, but was legal. Or cosine of cosine inverse, cross, pi. But pi was never allowed to go in. It was outside that domain. So there are some weird things that can happen with domain and range where you can't just cross. But then we're looking at an example right now where it's not even about crossing because cosine and arc sine or inverse sine don't even match up. One's a cosine, one's an inverse sine. Well, it's not even whether or not they're inverses, it's whether or not they're the same trig function, and they're not. So we talked about how over here normal trig gets us ratios. But the problem is to fill in these ratios we need a triangle, and we didn't have one, so we wrote one. Then I had them look over here to see, well, if they see a sine inverse, which arcsine means, and if they see something in a sine inverse, which this one has, they should have been able to label something in this triangle. So let's see what they were able to get. First of all, guys, if, oh, that's not what I want. Okay. If I draw theta right here, well, that's an awkward highlight. If I draw theta right here, do you guys know what this side could be? The 2. Because what's in the hypotenuse spot? 2. So what else can I label? The adjacent or the opposite? Because it's a sine. So that must be the opposite. So how on earth can I, being able to do math in my head, quickly say, oh, that's square root of 4 minus x squared, of course. What formula did I use? Pythagorean. A squared plus b squared is c squared. I said, in some ways, I don't know who you are, but I know you and I know you. So I can set up 2 squared is equal to a squared plus x squared. A squared is equal to 4, 2 squared, minus x squared. And a is equal to, now technically, wouldn't it be plus or minus if we were solving? Plus or minus. Well, this looks like a first quadrant triangle, so I guess my positive one makes sense, but they didn't tell me what quadrant to put my triangle, so maybe plus or minus is actually a better answer? Because maybe this was in the second quadrant, or the third, or the fourth. I don't know. But what do I know? If they ask for cosine, whether it's positive or negative, what should I put as my adjacent? And if you want, you can be super smarty pants and be like, I don't know, you tell me. Okay, fine. Plus or minus, I don't know. It's better than the book answer. The book, I think, just chooses the positive one without really telling you much. Well, that's lame. But hold on. That's just the adjacent. You can be a smarty pants and put plus or minus and say, I don't know. But what else do you need to put? Which is? Dun, 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 dun. Yeah.
I think why the book just straight put a positive because it says setting off a triangle because you can't really get a negative from the side of the triangle.
So maybe if it's like a geometric real life example, yeah. Yeah. What I see, Joe, is cosine in a midst of a chapter that allows, right, positive or negative. I think in some of homework they might give you the word constraints. Do you guys know what constraints are? Handcuffs are constraints. They constrain you. Okay? But like limits, restrictions, rules that have to be met, there are different meanings for the word constraint. But in math, what if they were to give you a constraint, something like P.S. X needs to be between, let's do negative pi over 2 and pi over 2. What's cosine in the first or the fourth quadrant? All positive. Students take calculus. Positive. What's cosine in both of these? Oh, so they would tell us, nope, 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 you're not allowed. If they give us a constraint, no, you can't put plus or minus. You have to put positive because in the fourth and first quadrants, cosine is only positive. So if they gave us some sort of constraint, some sort of characteristic or qualification that has to be true, okay, fine, then I'll give you the right sign. If they had given us like second quadrant or third quadrant, we would have had to choose negative. But that's only if they give us a constraint. Does that make sense? Only with a constraint would we choose just one. Otherwise, technically, you can be a smarty pants and put plus or minus. And you might be even better than the back of the book. But Joe, that's valid too. If they had to choose one, choose positive. It's more realistic. I get that. I get that. Section 4.7. Dun, 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 dun. Oh, there might be a word problem. We'll talk it over in class tomorrow. We need to go ahead and start 4.8. That was the objective today, was to do all of 4.8. No. The short, sweet version of 4.8 was supposed to be our objective today, because we're not going super crazy into those things called bearings. Nope. Which is another reason, Jason, as to why I need to check out your homework page. Make sure I didn't give any of those really hard ones from years past in section 4.8. But for right now, why are we going into 4.8 if everything got bumped today? Well, I say it's better to start on one day and finish the next than to try to cram it all in the next and just waste time today. Does that make sense? And some of you might be able to get started on 4.8 because today's Tuesday and maybe your Wednesday is really busy, etc. Because 4.8, you're totally allowed to use calculators. Some of you like that. We're basically solving triangle problems, but just not getting too crazy hard. Joe, go ahead. In some ways. Sometimes 360, sometimes 90. Sometimes 90. Sometimes. Right. But sometimes it's easier to say something like south 45 degrees west. Instead of doing north and then whatever, like 360 degrees, it's easier to start from south and go west. If it was early navigation where you had just the North Star, yes. But now that we have compasses with north, south, east, and west. Cool. Thanks, Joe. You know what was funny? Who was it the other day, the chapel speaker talked about? Oh, it was my pastor, Sarian, Brad Sarian. He was 2 chapels ago, right? 3 chapels? I don't know, it's a while ago. Oh, Mr. Carmichael was in between that. Anyway, he was talking about how he didn't like math. Oh, no, sorry, it wasn't chapel. It was Sunday, 2 Sundays ago. Anyway, he was talking about how his math teacher, he went to LAB back in the day, South Campus, a long time ago. But he's talking about how his middle school math teacher was like, you have to learn how to do these problems and show your work. What do you think? You'll carry around a calculator with you for the rest of your life? And he was like, yep. Anyway, with phones now. But can't we say the same thing with compasses? There's an app on your phone, pull out a compass. North, south, east, west. Just north, south. There we go. Anyway, just thinking about the craziness that is in your... That's cool. Just ignore. Unless you don't see them and they look scary and they have some sort of... Oh, their family's on a tour, you crazies. Okay, thank you, thank you, thank you. I'm fine. You guys are the ones that freak out. Anyway, section 4.8. Applications and models. Guys, does any of this strike you as odd? Draw and label a picture. You have the Pythagorean theorem in your back pocket as something you can use. You have trigonometric. Wait, what are trigonometric ratios? Maybe I should have put a trigonometric instead of trigonometry. Yeah, maybe cheater chart. I was even thinking if you're allowed to use your calculator, maybe I just mean you can use or set up fractions with sine or cosine or tangent, or cosecant or secant or cotangent, right? Maybe I'm just saying like, hey, remember, each of these are little baby formulas you can plug into. Inverse trig functions. Hey, if you have something like, what did I say, y over z? You can get to him using what? What can you use? Oh, that's a new tool that we have that we didn't have before. So let's check out and see. Oh, that's a negative. Anyway, let's keep going. So, how bad is the basic idea of section 4.8 going to get? Okay, this is the first problem. This probably isn't how bad can it get, but what's the idea? What do you have? Above the horizon. What's the horizon? Horizontal. We should all know horizontals this way. Horizon, where the sun rises and sets. Anyway, and we have the sun. Yes, I'm just going. Now what? Above? How do I do that? Makes no sense. 20 degrees is not a measurement. What is 20 degrees? A rotation. Oh, 20 degrees is like a little bit of like this. Oh! Are we making sense of this? 20 degrees is a rotation, right? It's not a length. It's not, oh, above. Okay, good. It's above, but it's a rotation. Actually, this probably should be lower. Anyway, that's okay. Where's the statue? It's 12 feet tall, right? But what's it casting? A shadow. Where's the shadow go? The sun is here and I'm here. Where's my shadow? On the ground. So there's a shadow like here? With a statue that's like here? The shadow goes here? Oh. Is the sun on top of the man? No. Where's the sun? Okay, he's probably up here somewhere, right? Hitting the man and making a shadow. Oh, science, it makes sense. Okay, so what am I supposed to be finding? The length of the shadow. But I don't, wait, Tyler, what else did I know? Yeah. Ah! So what do I do if I have an angle and an opposite and an adjacent? To what? Pythagoreans if I don't have enough. Trig functions. Trig let me take an angle and a side. So which trig says give me 20 and I'll give you opposite and adjacent? Oh, tangent, of course. Oh, that's easy. Easy. X is there. That's hard. Okay. But how do we get to X? Whenever you divide or have division, make it easier on yourself. What do? Multiply. But X isn't by itself. It's to be, because what are you going to do? Divide. Good. So X is equal to 12 over tangent of 20. Same thing as 12 cotangent of 20. But either way, pause. What degree? What mode do you need to be in? Degrees, please. Who already threw it in and got out an answer and you made sure you were in degree mode? And P.S., we need to label any word problem. This one's feet. What do we got? Anybody back them up? 9-6. Give me one more. Got it. 970. Oh, it's 969? And then it rounds up? Oh, got it. 970. Oh, that was rough. No, it wasn't. It was an introductory problem. Drew a picture, labeled, saw a trig that would solve. So now let's see if this one got any harder. A passenger in an airplane at an altitude of 10 kilometers sees two towns directly to the east. Pull out your phone. East is this way. Okay. Of the plane. The angles of depression to the towns are 28 and 55. Oh, sometimes they're going to give you a... Okay, if they say something about see figure, could it be below the words? Sure. Could it be above the words? Sure. Could it be to the right, to the left? Sure, but it should have figure and it should match up, right? Okay, so make sure you go looking for said figure. So what if said figure has a plane, a very pretty picture of a plane, and then has towns, very pretty pictures of towns? On the ground, we're assuming everything is flat because, frankly, anything else would be too complicated for you right now. See the town. See the town. What's the difference between angle of depression and angle of elevation? Sorry, I'm just labeling the 10 kilometers up. Looking down. Well, how do you look down? The town can look up to the plane, but can't the plane also look... Oh, could this be a passenger's line of sight out the window of the plane? And it looks down to town 1 and down to town 2? Oh. Which one's this guy? The little baby one, 28. Which is this guy? Must be the bigger one, 55. How on earth am I supposed to figure out this? Why is Joe saying opposite? Why is Joe saying opposite? What do you know about the lengths of both opposites? It's how high the plane is. It's how high the plane is. Couldn't I, using tangent, find this guy? And couldn't I, using tangent, find this guy? And that's a crazy hard problem. It's not too bad, because all you need to do is set up a little baby tangent with this dude who has the bigger angle with his 10 over x. And then set up a tangent with this guy. Oops, sorry, he's the 28, isn't he? With his opposite over adjacent. Can't I rearrange and have x? Rearrange and have y? Subtract the 2? Easy cheesy. Anyway, section 4.8, is it too crazy? No. Are we totally done with it? No. We can do some more examples after section 4.7 homework. Maybe we'll even just have some class time to work on homework. That's the nice time sometimes when everything gets budged a day and we maybe didn't need a whole day. That's all right. And then we can make sure, I can make sure your homework is all good to go on Google Classroom. Remember, I will post a comment in your section 4748 homeworks once I have double checked and made sure everything is good so that you don't have to do more work than you have to do. Does that make sense? How much time do we have? And 15 seconds. Wow. Take a nap, guys. So much time.